I told you about innate immunity being very old. The organisms that I work on, this slide's a little bit wrong. There are blue-green algae, fungi, dinoflagellates, and spirochetes. They're very old. Apicomplexans also are very old. And if we think about malaria-like organisms that are adapted to live inside red blood cells, you find just about every mammal and every bird suffers from one species or another of apicomplexian. And these organisms are, to me, incredibly well adapted for life inside of a cell. They have their own nuclear DNA that identifies them as a given critter. They also have mitochondrial DNA, and they have a third kind of DNA. This is a 32 kilodalton plasmid ring that codes for the enzymes involved in the dark phase of photosynthesis. So it's fascinating to look at some of the early papers on treatment of malaria with atrazine. Atrazine is a herbicide. And if you look at what's given to horses that have sarcocystis, there is a drug that's called Marquis. It's made by Bayer. That's another herbicide. And the fascinating issue is that people who have these apicomplexan infections have a tremendous amount of IL-10. I know John's going to perk up his head at that one, but specifically, they will downregulate inflammatory responses seen in Lyme. Lyme downregulates the inflammatory problems seen in Babesia, for example. And then these organisms all will make a toxin of their own. So malaria makes a toxin, the glycerophosphatidyl inositol, the GPI, is what the compound is. So, when I was working with GlaxoSmithKline looking at cholestyramine and Mepron together for a long-term duration of Lyme Babesia co-infected people, we had to look for true co-infection, and there are 300 people I had to go through who were identified as having Lyme Babesia infection who didn't. We found 30 total who met the criteria set up by Dr. Andy Spielman. He has since passed away, but kind of one of the gods of tropical medicine and Babesia in my mind. At any rate, what we have to do for those sarcocystis and Lyme patients is that you need to kill nuclear DNA, you need to kill mitochondrial DNA, which is what Mepron does. The missing piece is you need to kill the plasmid plant source of ATP in these organisms as well. That's what's missing. You also need to knock out their toxin formation with actose and then cholestyramine. We can do all that in horses, we can do all that in dogs. In the veterinary arm, maybe you guys can be thinking about what you're going to do for this huge problem in dogs and horses around the country.